Hey everyone, welcome back to the Deploy Securely podcast. Walter Haydock here. Today I'm going to be talking about a problem that is near and dear to my heart and at the junction of two areas that I've been focused on for a while now, and that is vulnerability management for AI. So, vulnerability management is already a really thorny problem. You've probably seen me post about some of the challenges of the common vulnerability scoring system and things like that. But unfortunately, adding AI into the mix makes it even tougher. For example, how do you identify a discrete vulnerability in an AI model, which might only be reproducible using the exact same context or user input, or is potentially not even reproducible at all if you're not using the same random weights or injects into the model? And given this situation, how would you describe the likelihood of exploitation of a given vulnerability, even if you could describe it unambiguously? And then additionally, how would you even know if a vulnerability is, quote, exploited, unquote? Using the exploit prediction scoring system, for example, you can discretely measure whether an attacker has attempted to exploit a given CVE because the sensors connected to the system will identify malware that's designed to exploit a given vulnerability or show any indications of behavior suggesting an attempted exploit of it. But we don't have that with AI. And I've been thinking about this problem because of a blog post by the Cybersecurity and Infrastructure Security Agency. So the post was pretty vague and focused on some obvious things, which are pretty typical of what CISA puts out. But there was one exception which got me thinking. And basically, they said that the AI engineering community must institute vulnerability identifiers like common vulnerabilities and exposures, CVE IDs. My bottom line take here is that if we're going to develop a vulnerability management and identification system for AI systems, it most certainly should not look like the existing CVE regime. This existing system is fraught with a bunch of problems. So, first of all, the relationship between a piece of software having a CVE logged against it and the vulnerability actually being exploitable is already highly non-deterministic. So 90% or more of CVEs are not exploitable in a given context, meaning that just identifying one in a given system doesn't really give you any idea as to your level of risk. Additionally, the National Vulnerability Database, which lists all CVEs, is full of what I would call science projects in my mind. These are issues exploited by researchers in extremely limited or controlled situations, which don't represent realistic vulnerabilities in most organizations. I'm sure they mean well, but these findings don't do a lot to advance real world security and do end up obstructing it by creating a lot of noise. And then the last thing I'll say about the existing system is the component naming problem, which I've talked about in other posts and other people have discussed a lot, makes it difficult to know whether a given CV even impacts a specific piece of software. And this is on top of whether the CVE can be exploited in that piece of software. I'm just talking about whether it is actually there or not. And this gets even more complex when you start talking about as a service products, where you have different services stacked on top of each other and then code stacked on top of that. And this gets even worse when you start talking about AI systems. And that's because CVEs already tell you so little about whether you're at risk or not. And there's a non-deterministic relationship between a CVE being present and you being at risk. And when you add AI, specifically, for example, large language models on top of this, you get an even less deterministic system. So it's even harder to tell what's going on. So assume that we follow CISA's advice and people start logging CVEs against AI models. You're going to have hundreds of thousands, millions of new findings, and it's going to be even more difficult to understand what's going on. And then what's to stop people from logging lots of science project vulnerabilities against these models and reporting them in databases like the NVD? And then, assume that we get these problems under control. How are we going to track and describe the exploding number of AI models, which, was a serious problem based on the naming issue that I described previously? What about the fine-tuned versions of these models? I hope the answer is not by trying to reproduce the existing system, specifically the common platform enumeration, which is is the way that the NVD describes software systems, because it's really just not getting the job done. So rather than just complaining about this problem, I decided to try to fix it. And I did that by building what I call the artificial intelligence risk scoring system. Going beyond just vulnerability management, it goes into quantifying risk in a standardized manner. So if you're interested in checking it out, please head to stackaware.com and go to the blog. I've got a 4-part series there describing the AIRSS. And if you want a penetration test of your AI models using the AIRSS, please also check out stackaware.com and drop me a line to set up a call so that we can get your AI systems assessed and tested for vulnerabilities in them using a more reasonable and rational approach than just logging CVEs against them. Thanks for listening today. I hope it's been helpful. And if you found it useful, please do like if you're on YouTube and hit subscribe if you're there or on one of the podcast platforms. Thanks a lot and looking forward to next time.